problem 4 of BMO 2025. How many different sequences of positive integers satisfy u1 equals 1 and this expression for all n greater or equal than 2? First of all, we observe that we start from u1 equals 1, then we can technically get in u2, plug it here. This expression, especially in this power, is always positive in the brackets. Then to this power, it becomes even greater, and so this numerator is always greater than denominator, and the sequence continues. However, the problems might start in the point where these numbers are no longer integer. So let's have a look. u3 is when we plug u2 here for n equals 2, expression is like this. So let's call this thing in brackets f of u2. Then for n equals 3, the expression is like this. Now u2 appears here. There was no u1. And so this is f of u3 over u2. And what is u3? It is f of u2. So f of u2 over u2 should be integer. What is f of u2? It is some binomial expression a plus b to the power of 2025. When we expand this expression modulo u2, it is still many things with u2, many, especially if we expand this u2 squared plus u2. And then in the end it is 1. So all of these equals 0 plus and so on plus 1 equals 1 modulo u2. So f of u2 equals 1 modulo u2. Then f of u2, when we plug 1 modulo u2, it is 1 squared. Why do we consider modulo u2? Because we have to divide by u2. That's why. So 1 squared plus 1 to the power 2025 equals 3 to the power of 2025 modulo u2. So the numerator is this, and we break it down. So there is some part divisible by u2, and 3 to the power 2025 divisible by u2. 3 is a prime, therefore u2 has to be 3 in the power of I when I goes from 0 to 2025. There are 2026 values overall. This is already some restriction, but we have to figure out, is it a final restriction or not? So we look at n equals 4 and write the formula like this, and then we plug, instead of u4, we plug of this expression, then this, and then we make it again look at as a function of u2, and this is very ugly. I tried this expression whether a over b is integer, then it doesn't mean that if and only if f of a over f of b will be integer. We don't know. So then what I tried to see that, look, this thing is 0 modulo u2, and so this thing remains also 1 modulo u2, and this is divisible. And this sequence repeats for not only for u5 but for the greater values of for greater indices, for 6, for 7, and so on. It repeats itself. Therefore the answer is 2026, and this finishes everything. Thank you.